Article 220.2 of the National Electrical Code specifically addresses permissible loads. Article 220.11 covers branch circuit calculations. Annex D provides additional guidance on branch circuit calculations. The National Electrical Code recognizes that not all connected loads operate simultaneously at their full nameplate ratings. A diversity factor allows a reduction in the total ampacity required for a branch circuit based on the expected load diversity. To apply diversity factors to computer equipment, follow these steps. Firstly, gather nameplate ratings. Collect the nameplate ratings and amps of all computers, printers, and monitors to be connected to the power distribution unit. Secondly, determine the diversity factor. For computer equipment, a diversity factor of 0.8 is commonly used. This means that only 80% of the total nameplate rating is expected to be the actual running load. Thirdly, calculate the load amperage. Multiply the nameplate rating of each device by the diversity factor, which is 0.8. Then sum the calculated amperage values for all devices. Let's consider an example. Imagine we have 10 computers with 5 amps nameplate ratings each, 5 printers with 3 amps nameplate ratings each, and 10 monitors with 2 amps nameplate ratings each. First, calculate the nameplate load amperage for each type of device. For computers, it's 10 times 5 amps, which equals 50 amps. For printers, it's 5 times 3 amps, which equals 15 amps. For monitors, it's 10 times 2 amps, which equals 20 amps. Next, calculate the total nameplate load by adding the individual loads together. 50 amps for computers plus 15 amps for printers plus 20 amps for monitors equals 85 amps. Now, apply the diversity factor calculation. Multiply the total nameplate load of 85 amps by the diversity factor of 0.8. This results in a total diversity factor load of 68 amps. Based on a diversity factor of 0.8, the actual running load of the equipment is expected to be 68 amps. This would allow for multiple computers to be connected to a 20 amp branch circuit without overloading the circuit. Always refer to the latest edition of the National Electrical Code for the most up-to-date requirements. Consult with a qualified electrician for specific guidance. This method should only be used when the actual running loads are known or can be reasonably estimated. Remember that accurate load calculation is crucial for electrical safety and code compliance. The NEC provides guidelines to help you determine the appropriate diversity factor for different types of equipment. Understanding and applying these factors correctly can optimize power distribution while ensuring safety and preventing overloads. Diversity factor is a ratio that represents the maximum demand of a system divided by the sum of the individual loads. It's always less than or equal to 1, reflecting the fact that not all devices operate at their maximum rating simultaneously. Applying diversity factors involves a few key steps. Start by identifying all the electrical loads connected to a particular circuit or system. This includes computers, monitors, printers, and any other equipment that draws power. Obtain the nameplate ratings for each piece of equipment. The nameplate rating indicates the maximum current or power that the device is designed to draw under normal operating conditions. Determine the appropriate diversity factor for the specific type of load. The National Electrical Code provides guidance on typical diversity factors for various types of equipment and applications. For computer equipment, a diversity factor of 0.8 is commonly used, as discussed earlier. However, it's essential to consider the specific characteristics of the equipment and the operating environment to determine the most appropriate value. Apply the diversity factor to the nameplate rating of each load. Multiply the nameplate rating by the diversity factor to obtain the estimated actual load. This adjusted load reflects the fact that the device is unlikely to operate at its maximum rating continuously. Sum the adjusted loads to determine the total estimated load in the circuit or system. This total load represents the demand that the electrical system must be able to supply. Compare the total estimated load to the capacity of the circuit or system. Ensure that the total load does not exceed the rated capacity of the circuit breaker, wiring, or other components. If the load exceeds the capacity, it may be necessary to reduce the number of devices connected to the circuit, upgrade the wiring, or take other measures to prevent overloads. It's crucial to consider the specific characteristics of the equipment, the operating environment, and the applicable codes and standards when applying diversity factors. Always consult with a qualified electrician or electrical engineer for assistance in determining the appropriate diversity factors and ensuring compliance with all applicable regulations. Additionally, regularly monitor the actual load in the circuit or system to verify that the diversity factor is still appropriate. If the actual load consistently exceeds the estimated load, it may be necessary to adjust the diversity factor or take other measures to prevent overloads. The National Electrical Code provides specific requirements for calculating branch circuit loads, including the use of diversity factors. It's essential to follow these requirements to ensure compliance and prevent electrical hazards. For example, Article 220.14 of the National Electrical Code specifies the minimum lighting load requirements for various types of occupancies. These requirements are based on the square footage of the building and the type of lighting fixtures used. Article 220.18 of the National Electrical Code provides requirements for calculating receptacle loads in dwelling unit. These requirements are based on the number of receptacles and the area served by each receptacle. Article 220.42 of the National Electrical Code addresses the use of demand factors for calculating feeder and service loads. Demand factors are similar to diversity factors, but they are applied to larger portions of the electrical system, such as feeders and services. It is important to note that the National Electrical Code is a comprehensive set of regulations that covers all aspects of electrical installations. It's essential to have a thorough understanding of the code and to follow all applicable requirements to ensure electrical safety and compliance. One aspect often overlooked is the impact of harmonics on electrical systems. Harmonics are voltage and current distortions that can be caused by nonlinear loads such as computers, electronic ballasts, and variable frequency drives. These harmonics can cause a variety of problems, including overheating of transformers and conductors, misoperation of protective devices, and interference with electronic equipment. To mitigate the effects of harmonics, it may be necessary to install harmonic filters or other mitigation devices. Harmonic filters are designed to reduce the amplitude of harmonic currents and voltages, thereby improving the power quality of the electrical system. Another important consideration is the grounding system. A properly designed and installed grounding system is essential for electrical safety and for preventing equipment damage. The grounding system provides a low impedance path for fault currents to flow back to the source, which allows the circuit breaker or fuse to trip and clear the fault. The National Electrical Code specifies detailed requirements for grounding systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metallic components. Surge protection is another critical aspect of electrical system design. Surges are transient overvoltages that can be caused by lightning strikes, switching operations, or other events. These surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protective devices are designed to divert surge currents away from the equipment and into the grounding system, thereby protecting the equipment from damage. The National Electrical Code requires surge protection for certain types of occupancies in equipment. Power quality is a broad term that refers to the characteristics of the voltage and current supplied to electrical equipment. Poor power quality can cause a variety of problems, including equipment malfunction, reduced equipment life, and increased energy consumption. Factors that can affect power quality include voltage sags, voltage swells, harmonics, and transients. To improve power quality, it may be necessary to install power conditioning equipment such as voltage regulators, harmonic filters, and surge suppressors. Energy efficiency is another important consideration in electrical system design. By using energy-efficient equipment and implementing energy-saving measures, it is possible to reduce energy consumption and lower electricity bills. Some common energy-saving measures include using LED lighting, installing occupancy sensors, and optimizing HVAC systems. The National Electrical Code includes requirements for energy-efficient lighting and other equipment. The use of proper wiring methods is crucial for electrical safety and reliability. The National Electrical Code specifies detailed requirements for wiring methods, including the type of conductor, the size of conductor, the type of insulation, and the method of installation. It is important to follow these requirements to prevent electrical hazards, such as fires and electric shocks. Proper overcurrent protection is essential for preventing damage to electrical equipment and wiring. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The National Electrical Code specifies the requirements for overcurrent protection, including the size and type of overcurrent protection device, the location of the overcurrent protection device, and the coordination of overcurrent protection devices. Electrical safety is a paramount concern in all electrical work. It is important to follow safe work practices and to use appropriate personal protective equipment to prevent electrical shocks and other injuries. Some common safe work practices include energizing circuits before working on them, using insulated tools, and wearing rubber gloves and safety glasses. Regular maintenance and inspection of electrical equipment are essential for ensuring its continued safe and reliable operation. Maintenance activities may include cleaning equipment, tightening connections, and testing components. Inspections should be performed by qualified personnel to identify any potential hazards or problems. Proper documentation of electrical systems is crucial for troubleshooting and maintenance. Documentation should include wiring diagrams, equipment specifications, and maintenance records. This information can be invaluable when diagnosing problems or performing repairs. Staying up to date with the latest version of the National Electrical Code and other applicable codes and standards is essential for all electrical professionals. The codes and standards are constantly evolving to reflect new technologies and best practices. Continuing education and training are important for maintaining competency and ensuring compliance. Collaboration with other professionals, such as electrical engineers, architects, and contractors, is often necessary for complex electrical projects. Collaboration can help to ensure that the electrical system is properly designed, installed, and maintained. The effective communication with clients and other stakeholders is essential for building trust and ensuring that their needs are met. Communication should be clear, concise, and professional. Problem-solving skills are essential for troubleshooting electrical problems and finding solutions. Problem-solving involves identifying the problem, gathering information, analyzing the data, and developing and implementing solutions. Ethical conduct is paramount for all electrical professionals. Electrical professionals have a responsibility to protect the public safety and to act in accordance with the highest ethical standards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for assistance with electrical projects. Remember that safety is always the top priority in all electrical work.